Solving systems of nonlinear equations. So for our first problem, we're given this graph of a line and a parabola, and we're asked to write the system of equations that's represented. Let's start with the line. When you're trying to write the equation for the graph of a line, you always start with the y-intercept, which is b. After that, you look at how you would have to move to get to the next point. Now, when I say the next point on the line, I don't mean something just like in the middle, like here, where I can't tell where that is. I mean a clearly defined point, right? Any of these will work. So to get to the next clearly defined point, I have to go up 1 over 1, up 1 over 1. That means that I have a slope of 1. And I already saw that I have a y-intercept of -5. So to write the equation of my line, I'm going to use y equals mx plus b. That's my slope-intercept form. And my m is 1, so I can just write x minus 5. So that part is easy. Y equals x minus 5. Now let's talk about the parabola. For the parabola, remember that we have the vertex form of a parabola as this, where A is the scale. So if we are multiplying everything by 2 or by 3 or by -2 or -3 or so on. H is the number of spaces I move the vertex to the left or right. And K is the number of spaces I move the vertex up or down. The vertex always starts at 0, 0. So you can see here that the vertex has moved up 1 spot, which means that this K right here is going to be a 1. The vertex has not moved off of the axis, so it hasn't moved anywhere left or right, which means that our H is going to be 0. And now let's look at A. If I start at the vertex, I go over 1 down 1, and I'm on the parabola. Over 1 down 3, and I'm on the parabola. Over 1 down 5, and I'm on the parabola. And that's the basic shape of the parent graph, is over 1 down 1, over 1 down 3, over 1 down 5. So A is going to be 1. There's no scaling going on here. So make my equation, instead of writing, I don't have to write 1. I can just leave that part out because it's implied. Instead of writing x minus 0, I'm just going to write x squared and then plus 1. So there's my system. Solve the system. So since both of these equations are equal to y, they're both equal to the same thing. That means they're both equal to each other. So that's what we're going to do. We're going to set them equal to each other. You can also think of this as using the substitution method, because we're simply, since we know that y equals x, we're simply replacing this y with an x. Right? You can think of it that way too. All right. So we've got the equation that we're given on top, x cubed minus 2x squared minus 3x plus 8, and that's going to be equal to x, right? They're both equal to y, then they're both equal to each other. We're going to solve by subtracting x from both sides so that we can get this bad boy equal to 0. And once we've got it equal to 0, we should look to see if we can factor. So I'm going to look at the first two and then the second two. And in the first two terms, I can factor out an x squared. And then I'm left with x minus 2. Now, I want to be left with x minus 2 here as well. So what can I take out? What can I divide by to make sure I'm left with x minus 2? What do you think? Yeah, a -4. So now I'm going to take the x squared minus 4 and put those in their own set of parentheses, and then the x minus 2, and remember it's equal to 0. So let's move things up here so we have some more room. And now I'm going to solve. So x squared minus 4 can be factored further, and then this one is just going to stay x minus 2. X squared minus 4 is a special pattern in factoring where we're missing the middle term. Anytime you're missing the middle term, you should have little alarm bells going off in your head. That means that one has to be a plus and one's a minus in order to cancel that middle term out. All right, so now let's solve these. We've got x plus 2 is equal to 0, and x minus 2 is equal to 0. Here we get x equals negative 2. Here we get x equals positive 2. But alas, we are not done, because when we're solving systems, we need an x and a y for each intersection point. So let's plug this x value into this equation right here. And what do you get? You would get y equals negative 2. Oh, that was easy. Same thing would happen for this x value. Plug it in right here, same spot, and you would get y equals 2. So one of our intersection points is at negative 2, negative 2, and the other one is at 2, 2. And as always, with any time you're solving systems or solving equations, you can always plug your answers back in and make sure that they work. All right, last one. And this one's missing something. I'm not sure how it got dropped off, but this should say equal to 13. All righty. So in this one, we're going to use substitution again. And it looks like the easiest variable to solve for would be this y, because all I'd have to do is move this term over. So since that's the path of least resistance, that's the one I'm going to choose for this problem. So this equation is going to become y equals x plus 1. And now I'm going to take that x plus 1, and I'm going to plug it in right here for y. So I'll have x squared plus x plus 1 squared equals 13. And I have to FOIL that out. So when I FOIL x plus 1 times x plus 1, I get x squared plus 2x plus 1. And let's combine our x squareds. We've got our like terms. We've got 2x squared plus 2x plus 1 is equal to 13. To solve it, it's a quadratic, so get it equal to 0. Let's move this over. So we've got 2x squared plus 2x minus 12 equals 0. I'm going to write that one up here. When factoring, always look for that common factor that you can take out first. And then we're going to do quick factoring. Well, actually, since we're solving, from this step, after we factor out the 2, we can divide both sides by 2. Because remember, we're not just factoring to get the factors, we're solving here. So we can eliminate that 2. You would not eliminate if you were just asked to factor, then that 2 needs to be left in there. But here, since we're solving, we can eliminate it. All right, and this is going to be quick factoring. So I'll put an x here and an x here. And I need 2 numbers that will multiply to be negative 6, but add to be positive 1. And those 2 numbers would be, got them? Thinking of them? Multiply to be negative 6, add to be positive 1. So we need a positive 3 and a negative 2. Solve each of these. X plus 3 equals 0, so x is negative 3. X minus 2 equals 0, so x is 2. And as always, we have to plug back in to find y. So I'm going to use this equation because it's a lot easier. So for the first one, let's do x equals negative 3 first. We're going to have y minus negative 3 equals 1. Right? I'm using this equation right here. I'm plugging back in. So then that would give me y plus 3 equals 1. So y, subtract 3 from both sides, is negative 2. So here's my first point, negative 3, negative 2. Now let's do the other one. Now let's do x equals 2. Plug into that same equation, y minus 2 equals 1. Add 2 to both sides, and y is 3. So here's my other point, 2, 3. And those are the solutions to my system.